What's up, folks? I'm going to go over the quiz here, see if we can learn some things. I did check it out. You guys actually did better than they did last year, so 78%. I think 73 was the average last year. And what I'm impressed by is this biggest bar here at 100. Retakes probably about here on over. So if you're watching this, you're probably in here. Probably don't want to hear much about this one over here, but just something to kind of think about how you did overall. Let's get into the multiple choice right away here. Let's not think around. What is the acceleration of a car that maintains constant velocity of 55 for 10? So it's kind of tricky because this is in seconds and this is in miles per hour. So you can like eliminate this one right away because it's miles per second per second. We need miles per hour per second. So when you divide by 10, it's going to make it smaller. But if you read carefully here, it says constant velocity. So it's kind of a trick question. If constant velocity, your acceleration is actually 0. So 63% on that first one. So just remember, if it's constant velocity, there's no acceleration. Here in this question, it says base your answers to the question on the graph below, which represents the motion of a car. So y-axis says velocity. This means that we have constant acceleration, and then we're going to hold a constant speed. The best approach, rather than doing two different math problems, magic physics formula-wise, because we have constant acceleration and constant velocity, is probably just to count up your boxes. So each box looks like it represents about one. No, this is 2.5 and 1, so 2.5. All these are 2.5, and then these boxes here must be more, probably 5. So if you count up all your boxes here, the correct answer is 340. So there must be 40 boxes underneath this curve, or boxes that are equivalent to 40. So once again, correct answer is 40. Looks like, oh, 82%. Look at us. Here we have another velocity time graph. Notice that we have constant acceleration here, which means you have options. You can either use magic physics formulas, or you can kind of go through and solve. Probably best approach would be to count the boxes up to 4. So if you count the boxes up to 4, you get about 40 boxes worth. Each box is worth 5. So this would be like 2.5, 2.5, 2.5. Count up all the boxes areas, you get something that is equivalent to 40 meters, 68% on that. This one came right from the practice. Anytime you see in a position time graph, now it says displacement, but that means position. Anytime you see a curve like here, that means acceleration. Then we have constant speed, then we're not moving, then we're moving with a constant speed backwards. So moving forward with constant speed would be from B to C. So you can see 78% of us were able to figure that out. Here's one that we saw on the velocity time graph below, which is on the practice. Which of the only letter that shows constant velocity? So only B is showing our constant velocity here. Now you could make an argument that this is constant velocity too, A, but it's a constant velocity of 0, so B is the better response. No problems with this, 100% correct. Then we get into this whole chart. Charts should not be all that difficult. You just have to kind of go through and multiply. For example, it'd be like 10 times 0.5 and get 5 for the distance, then 0. When you're all done, you add up that column. You should be getting something for 5 for our totals. 80% of us were able to do that. Then for the other one, coming through and adding up times, uh, 97% of us could get 2.75. That's really all you had to do is go through and add those up. We'll hop down to more multiple choice questions, and we'll come back and do the T-catch problem at the very end. It says a baseball pitcher delivers a fastball. During the throw, the speed of the ball increases from 0 to 30 over a time of 0.1 seconds. So 30 divided by 0.1 is the same thing as saying 300. So 62% of us were able to do that. Let's see. This next graph we had, and this is, I had the key marked wrong. So if you took this in its first or third period, I had to go back and make some changes here, but I had the key marked as 20, but the correct answer was 60. 20 is just the top triangle. You have to also include in the square on the bottom. So when you do that, you actually end up with something that's 60. So you can see I had it marked here as number 1. Now I didn't take off if you were these 3 people. You didn't go back and lose it, but if you are here, which 67% of us, I had to go back through and add those in. So you may just wanna double check that I did go through and add that in for you, okay? Just run a double check on that. Car A passes car B, then car A must be what? The correct answer is moving faster than car B, but you don't necessarily have to accelerate. You don't have to go really fast. I thought that would be a little higher. 56% on a question like that is kind of low. Looks like 7 people are moving faster than car B and accelerating. Remember, you don't have to accelerate. You can pass someone going faster. You don't have to accelerate. 73% on this one. We understand the difference between distance and displacement. So our displacement was 16, and then we had to go back and add in 8 more. So when we add in the additional 8 more, we end up with a total of 24. Good job, 73%. Here's one I heard a lot of people complaining about how fast this fullback is. I thought was kind of funny. The fullback is running down the football field in a straight line. He starts at the 0 line at 0 seconds, at 1 he's at 10, at 2 he's at 20, at 3 he's at 30, and so on. But what's going on? Well, we're moving with constant speed, 100%, no problems here at all. I'm going to work our way back to the whole t-catch problem. I'll try to find like letter A here, and then we'll kind of start to work through these. It says, what time does a police officer catch the speeder? We're about 82% of us between 5.2 and 5.3. So if we look here, I've set it up, the graph, so you could see the intersection. That's how I'd recommend doing it. Notice what I'm putting in here. 40x is constant velocity, and 7.5 is 7.5x squared is constant acceleration. Where they cross is 5.33. So you can see that fits in the range here. 82% of it fit the intersection. And when it comes to the distance, that comes with the intersection as well. So the distance is the y, 213. So 213 fits us right in the range as well. So remember, now you can start applying the half rule. Everything's going to be half of something else. So like when it's asking about the speeder, okay, and we try to figure out when they'll have the same velocity, we can use this representation, y equals 40, and y equals 15x. So this is constant acceleration times velocity half the time, and they have the same distance, 2.67. So letter C probably asks, what time will they have the same velocity? Let's see if I can dial down letter C here. What time do they have the same velocity? Between 2.3 and 3, so if we half that. Then there's probably going to be some questions about distance. Because when the speeder and police officer have the same velocity, what is the position of the speeder? So if we were to go through and look back at this graph, if I come to a time that is half of this and come up, it's talking about somewhere in here. But it's a lot easier if you just put in your calculator, 213 divided by 2, that's 106.5. Probably like somewhere in here is like what we're talking about. 108, 10, there it is right there, 106.5, half the time. Now, if I come down here, I can actually figure out what it would be on here at half the time. So if I have this number 106.5 again, I end up with 53.25. So I'm right around there-ish. I don't think I'm going to get lucky this time and hit it. But anyway, it'd be at the same thing. So that's what that questions are. Let's see how we do on those. That was D. We had 72% of us. How about E? 67%. All you had to do is half the other answer. So if 73 got that, not sure why it wouldn't be the same percentage again. Like, why are we dropping when all we have to do is do half again? Not sure, really. Maybe confusion on who's who. But anyway, that's kind of the quiz. Hopefully it went well for you. I'm going to go ahead and open up the retake right now, and then you can hop in there and see if you can improve. If you have any questions, feel free to message me in Canvas. I'll be here at school all day while you're at home. Not that I'm bitter. Not that I'm bitter. All right, have a great weekend. We'll see you guys on Tuesday.